My name is Janelle Haines. I currently work for John Deere. I'm at our Harvester Works facility in East Moline, Illinois, and I'm the ergonomic engineer for them. Just a little bit on my background. I went to the school at the University of Iowa and then studied biomedical engineering. And I focused on ergonomics and biomechanics, which is how I ended up at John Deere, because a biomedical engineer does not typically belong at John Deere. But it's worked really well. I've been with Deere for 5.5 years now, and I've really gotten to be submerged in the VR world and the safety world for the duration of that time. So I spent some time with the virtual reality group and then moved to the safety group and was able to kind of use those tools that I learned about and kind of use them to prevent injuries, which is what we're going to talk about today. This is my second year speaking at this conference. Last year I was 32 weeks pregnant, and I'm very happy to say I am not 32 weeks pregnant today. But I just have to show you, this is my daughter. She's the best and she's super sweet, so just had to share that with you today. All right, so today I want to just give you a brief overview on John Deere, go through the virtual reality system that I currently use and some of the software and things like that. And then really talk about virtual reality in the manufacturing environment, because there's tons of uses for virtual reality. And even within John Deere, we use it for different things. I'll mention a few of them, but what does it look like specific to manufacturing? And I'll just kind of walk you through a few of my example reviews. And then we'll just talk about additional benefits to the company that it can have. So John Deere is committed to the success of those linked to the land. And we do more than combines, believe it or not. We have our Ag and Turf division, and then also our Construction and Forestry division. So we build a lot of cool stuff. I've gotten to drive a lot of big machinery, and it's awesome. And then we have our supporting operations as well. And just a little visual, John Deere is worldwide. We have dealers and facilities all over the globe, so it's a really cool company to work for. All right, so the virtual reality system. Each system is made up of a few different things. I'll actually start at the bottom. We've got our display device. There's tons of display devices out there. You can go out to our vendor floor and look at a bunch of them. We choose to use the HTC Vive, and even that has kind of emerged over time. We used to use an older one from Rockwell Collins, and now we've moved to the Vive. It works great. You have your VR software, so just a program that loads and displays your geometry, and then that also reads your input devices and can compute those displays for you. So for myself, I use the classic Jack software a lot, but then also use the IC-I-Do software. Both have strong points and both have limitations. That's software, right? We have to find the stuff that works best and adapt to make it work best for us. Then we have our motion tracking system. So that's going to be the cameras that are picking up your input devices. We need those input devices to make the experience as real as possible. When I put somebody in the headset, I not only want them to see the environment, I want them to feel it. So when they pick up a battery gun in the environment, I want them to really pick up a battery gun and have it fly around with them. I want to submerge them as much as I can. So for our motion tracking, we, again, have two different systems we can use. We have a Vicon camera system, which works great, but then also the Vive tracking actually works pretty well. That comes with the headset. So, like I said, we have lots of uses for virtual reality at John Deere. We use it to show customers new designs of cabs. We use it for cab visibility, serviceability, things like that. But what does it look like specific to manufacturing? We want to use it to find proactive solutions, and that's my main goal. How can I prevent injuries on the floor? It's by figuring them out before they're actually a physical threat. So I want to look at the designs, I want to look at the workstations, I want to look at that process while it's in the design phase, 2 years before production. so that I can identify the threat before it's a physical problem on the floor. And that's where we're gonna get ahead of injuries, and that's where we're gonna really make the headway. So that, to me, is the biggest asset of using this for manufacturing. Then we wanna use it to analyze costly tooling. Obviously, sometimes we might look at a process, an existing process, and say, you know, if we implemented this rotating fixture, it would fix the problem. Well, we hope it would, right? But by throwing it in a virtual environment, you can ensure that before you actually spend $250,000 on a fixture that might solve your problem, but it might not. So we do that, and then we use it to get buy-in from lots of different groups, because obviously in a large company, it's not just one person that gets to make the decision. You need lots of OKs for that. So a little about my process, I guess. To set up a review, I get the geometry from that design engineer or whoever that is kind of running the project, and I convert it just to make it fit with our software. And then we take it into the lab and we bring assemblers or welders or just production employees off the floor, you know, those people that have the most experience, those people that know the process best, put the headset on them and give them those props to make it as real as possible, and then have them go through the steps of the process. So what can we look at in manufacturing? We can look at assembly procedures. So what's the fit? What's the reach? You know, are they gonna be able to hand start that bolt? I don't know, let's look. We can look at layouts, so super helpful when you're going under like a factory redesign or a line redesign, you know, positioning for fixtures and tools and even just racks and parts. It's very helpful for that. And then you can look at fixtures, like I said, specifically weld fixtures. You know, what height do we need? What specifications do we need? Do we need it to rotate fully, you know, 360, or do we just need 45 degrees of rotation? All that is really helpful to know ahead of time. So these next slides are really just pictures, and we're just gonna kind of talk through what goes on in my brain when I have a review. So what you're seeing, the top left corner, is just a webcam picture. So in each review, we take all 4 of these shots. So we want to be able to see the operator's actual physical position, right? Because for me, an ergonomics engineer, I'm very concerned with posture problems. So this is very valuable to me. Then I want to be able to see also the operator in relation to the geometry that we're looking at. And then the bottom is the left and right eye view. So that just helps, I mean, it's what they're seeing, and then it helps us know, like, visibility-wise, what's going on. So in this example, we have an operator. He's in a frame. Obviously, it's very tight, and he's trying to make a connection underneath. It's a blind connection, so right away on the safety side, we know we've got hand and finger risk for injury there. He can't see what he's doing. Then if we look on the ergo side, he's crammed up in a little space. His knees are to his chest. He's bent forward, and he's craning his neck to the side to try to see that blind connection. So when I look at that, I say, I see a lower back injury. I see hip issues. I see a potential for neck injury. It's a whole mess. So it's those things that we want to identify. Same concept here. This employee is needing to tighten a fixture on the underside of a tank, holding a backup wrench, pushing with a manual torque wrench, but he has to lean up against the machine. So literally, he's like supporting himself by leaning on his chest. So how is he supposed to get any strength and power through his arms? Very little. So we see, you know, issues with contact stress. We see risk for shoulder injury. And again, it's a blind connection up there, tightening up there. So what can we do to improve that and get him in a safer position and just a safer overall process? This one was kind of cool. This operator is just installing a drive shaft, and they needed a mud shield on it. Simple, right? He just needs to literally hold it up and tighten a few bolts down with the battery gun, but the shield blocks everything. So anytime you've got a power tool next to your hand and you can't see it, that's a recipe for disaster. So we worked with the design engineers, and they were able to just cut a small hole, nothing huge, right? It's small, but it's enough so that he can see his hand, he can see where the gun is, and it improved his posture. So it was kind of like a safety improvement with a little bonus ergo improvement, which was great. And then this last one is really one of my favorites, I guess. I don't know, I have a lot of favorites. But so we have operators who work in big tanks. And the assembly, I would say 75% of their assembly work each cycle is below their knees. So they have two options. They can either kneel, which we all know kneeling kills your knees, and from an ergonomist point of view, it's terrible. Or he bends over and leans on the side and does all the assembly work one-handed, which also is terrible. So now we're either going to take a knee injury or lower back. So we were really trying to determine what can we do? And so we took it into the lab, played around with a lot of different configurations, and we're able to rotate that tank to get him in the best position possible. So this was just some of our iterations. First picture obviously is what he was doing. So we said, okay, well, what if we rotate the tank? Because in VR, that's a huge benefit of VR for manufacturing. Even if you don't know exactly what solution you're going for, it doesn't matter. It's VR, you can do whatever you want. You can float it 30 feet in the air, although don't work under suspended loads. That's really bad for safety, but you know what I mean? The opportunities are endless. So there's no stupid ideas. You can play with it for free, essentially, because you've already got the review up and running. So we just said, okay, what happens if we rotate it? Well, okay, now he's not kneeling, right? But it's too low. He's still bent over. We still are gonna see a lot of issues with lower back and potential for lower back injuries. So what if we sit him on a stool, right? Okay, good. Now he's not bending over or anything, but now the work is kind of chest level. And so every time he's raising a battery gun up, your arm's going over shoulder height. Not ideal. So what if we rotate it and put it on a Z-axis positioner, which now allows us to adjust the height for any operator, and that's where we get our good ergonomic position. And that's really what we're striving for in all of this. So we can reduce those injuries and make it adaptable for any size operator. So does it pay off, right? Does it really help? If we look at these and we're trying to prevent the injuries, does it pay off? Well, if you have an elbow claim, right, or a carpal tunnel claim, one carpal tunnel claim can be $60,000. So if you're looking at bilateral, that's $120,000 minimum. A shoulder claim can be $120,000. A back claim, you're looking at a minimum of probably $170,000. So if you spend an hour, doesn't even have to be an hour. Some of these reviews are 30 minutes, right? If you take the time to go in and review a process and reduce one back injury, stand the guy up, figure out a way to get him from bending over to standing up, you can save $170,000 in 30 minutes. I think it pays off. Not only does it, so it's going to be incredible for your workers' comp budget, and then it improves your operators' quality of life and work, and that's really what we're striving for. So then just some additional benefits to go along with that. Obviously, if we are looking at these things, we're going to be improving our safety and the safety of our factory and the safety of our employees. And as safety team members, I think every factory or every company is trying to do that, right? We want to provide a healthy and safe environment for our workers. So absolutely, checking things in virtual reality for these manufacturing processes does that. Along with safety, if we now have checked and have our operators in healthy postures and in positions where they can reach the work they're supposed to be doing and can see the work they're supposed to be doing, that obviously improves the quality, right? Because how great of a torque am I going to make if I'm that guy leaning up against the machine with a backup wrench and a torque wrench? The quality of that torque is going to be probably pretty poor. But if I can put him in a position where he can use his body to his advantage and really have full strength, the quality of that torque is going to go up. And so by checking these things, your quality is going to go up. And then along with quality and safety comes efficiency. If I can work safely and have access to everything and see everything, I think people are going to be able to work more efficiently and more productively. And those are really the things we're all striving to do in our companies, right? So absolutely it pays off. It comes with additional benefits. It seems kind of like a no-brainer to me. And really that's all I have prepared for today. Really just, this is how we're using it. So if there's any other questions, I'd be happy to answer them. Yeah.